Today we have the same question as yesterday. We're given the prime numbers and we ask to find the minimum number x such that x or bitwise x plus 1 is this prime number. So the solution is the same as I explained yesterday. The forward operation is let's consider some prime number, like I don't know, just number, not exactly prime. The x or x plus 1. The x plus 1 does changes this tail to zeros and set the rightmost 0 to 1. This is x plus 1. Now the OR operation is we have the same bits, just right where any one is here. And the opposite reverse operation is we have to take the, for example, if we have this tail of ones, we know that this bit was 0, so we have to change it to 0. This is a reverse operation. I don't know why this doesn't work with this example. Okay, let's forget it for now. So to do this kind of operation, I use first I use inversion of the bits. So inverse bits would be this. Now I use now let's look at my solution. Take the lowest one bit. So the lowest one bit is lowest one bit. It's actually the same for this example. Now I do the XOR this original number, and this gives me this solution. I'm sorry, forgot one little detail. I shifted right. So before XOR I shift to the right. So this becomes like this. And now I do the XOR operation. 1 1 0 0 1 1. So this is the answer. And this series of operation is the algorithm I implemented. However, there is another possible solutions, and one of them is, imagine we have some number like this, or not, like this, and we want to change this bit to 0. So first we remove this part. So this is a +1 operation. +1 operation gives the same, but all zeros at the tail. Now we do AND operation. AND operation. This became all zeros, just the head. And now we do plus operation. So this previous plus this one. And the plus operation just writes the tail as is. Tail is preserved, but the head is multiplied by 2. Head times 2, because it adds to itself. And in binary, to multiply by 2, you just do shift left by 1. The same operation. So it is became 1, 1, 0. We shifted left, and this is 0. And now we have to just shift left, shift right. Shift right by 1 or divide by 2. So shift right by 1, 2 zeros in the middle, and 2 ones left. So this is answer. It's the same as in the previous example, but it is a different set of operations. And it's kind of tricky, tricky implementation. So you have to do very proficient in bit operations to know this kind of trick. So you can shift head by 1 bit, by 1 position. Now let's look at the implementations. The Kotlin is kind of trivial, and the Rust implementation is the second that I described. Here it is. It's n and n plus 1, and then plus operation, and finally shift by 1 position right, or just divide by 2. Well, that's it for today.